Good afternoon. We're talking about generating code in Go today. The core idea of this presentation is to take a look at some of the problems, take a bit different look, take a step back, and see generating code. And see generating code as a way to approach them differently and to maybe pick generating code as a solution to those problems. With that seed in mind, I am Daniel Antos. I've been working with Go in Pento as a staff engineer for a few years now. And maybe what's the most important is that I did not like generated code. And this is the main reason I'm doing this presentation, to show you a little bit of my journey that I went through. When I first came to Go and I had to generate mocks, I was very surprised that you have to do that you can't use reflection, and I did not understand why I would do that. But here I am, a few years down the line, talking to you about a completely different approach to accept generated code. And this is what we're going to be talking about today. First, we're going to start with the why, because if there is no problem, then what is this presentation about? Then we're going to bring everyone up to the same level around basics of generating code in Go. Then we're going to go through the three main areas where I found generated code to be one of the best solutions and very inspiring for myself. And then we're going to go through everyday life with generated code, some of the challenges it creates and some of the nice, I call them hacks, that you can use to make our everyday life a little bit better. So why? What problem are we solving? So first of all, it just so happens that code generation solves many of the problems that can be solved with reflection. But compared to reflection, you do have compile time safety, meaning if you make a mistake, compiler, your friend, will catch that, and it will show you a nice error by building where it points you, hey, you forgot to update this part of your code. And compiler, compared to you, it will not forget. It will always check all of the places. Another part is reducing abstraction. While abstraction is good and we often need it, there are places where we use it maybe a bit too extensively, and it always has its own cost of reducing performance, of making code more complex. And in many of those places, we can also take a step back and think, okay, can I solve it a bit differently? And you probably had that in the very beginning of your programming careers, that you solve one problem quite easily. I think Hello World is a great example where you can see your evolution as a programmer, where you start with simple print and then you kind of evolves. And at some point you come back and you're like, simple print was enough. And with code generation, you can kind of get to a similar place where you do not introduce abstraction for the sake of it, for making you write less code. You can use code generation to write code that is very similar to what you would have written yourself. And last but not least is about not repeating yourselves, right? Like, we write programs to solve some of the problems of people repeating the boring tasks they have to do. Our programs save people time. Why not use similar approach to our own job as well? And let's go into some basics of generating code. code generators are usually a simple CLI tools. They are often, if we're talking about Go, they will be often written in Go due to how awesome standard library is. It has a lot of helpful libraries that will help you parse the code, that will go over this code. And those generators, they will take some input, maybe a template, maybe existing code. They'll do their magic and they will output you a code that hopefully compiles and you can use. And I see code generation as something that is almost first citizen in Go. It has been in Go for a long time, since version 1.4. And Go has this nice special command called GoGenerate that allows you to save the command that you used to generate something and put it in code. And on one hand, you might be thinking, well, that's not so special, like I can put it anywhere else. But on the other hand, it leaves a trace for any future developer, including you, that this command has been run here, and it should have been run again in case something has changed. And Go even has in its toolchain GoGenerate command that will take all of the GoGenerate commands in your package and it will run them for you, so you don't have to find them and run them manually. It comes into play very well, especially in everyday life. We're gonna get into that a little bit later. Let's start with the first great use of generated code. It's gonna be generating your APIs. So this is the first place where I actually understood why I'm supposed to do that in some of the cases. And it was with GraphQL. In my team, we used to write it by hand. We first would write a schema, and then we would write Go code that was supposed to mimic that schema. And we had a new joiner who asked, like, why do you do that? And that was the start of my change in my mind, because after discussing it with him, he mentioned, hey, you already put a lot of work into making sure that your schema is correct. You spend a lot of time talking with other teams, with front-enders, with people who will use your service, within your team about schema. So you focus on it. And this is what's important. And once you have that schema, why do we even care how the Go code that is going to be produced looks like? It's more about it should be working the same way you expect it based on schema. So you can take that first schema-first approach, point it towards whatever you're using, some Protos, maybe some GraphQL, and ask it to generate code for you. And that's what we did. And it brings like we mentioned, the schema at the first place, but it also reduces a lot of complexity that comes with executing everything in the runtime, because many other libraries that will not do that, they'll have to check your schema and they'll check your code when the path is hit. With generated code, it happens during the compile time. And this is one of the examples. You can use one of the proto generators for gRPC, and it's gonna generate the upper part with an interface. And then you can implement that interface, and that's what's on the bottom of the page. And you don't have to do anything else than create your schema, generate your code, and then start thinking about what's important for your business, which is your domain, your business logic. Second part is generating your ORM. It comes from the same principle. You already written your migrations in SQL. You already have your schema in DLL, like DLL in your database. And this is the source of truth. Doesn't matter how your models look like. Your database is where it comes. We're talking here mostly about SQL. We're talking here mostly about SQL because it does give you all of the types. If something is a nullable, it can be nullable in your code. But if it's not nullable, it doesn't matter what you have in your code. And with generated code that takes a look at your DLL, there is no way of making a typo. You cannot forget about renaming something in your code. Once it gets changed in your database, and you ensure that the code is always generated afterwards, you will never make that mistake again. Your compiler will always find it. I don't know how many of you had a pleasure of debugging your ORM when something doesn't go wrong, when something goes wrong. When I kind of look at the methods that are used by ORM, this is kind of what I always want to be on the other side. When I have my find method, I want there to be SQL because that's what I'm working with. But due to high complexity of reflection and what the ORM has to do to get you to a point where you don't have to write your SQL by hand, it creates so much complexity that if there is an issue somewhere down the line, you're not gonna see this. You're gonna see many, many, many levels of abstraction that you have to understand, and that is fine until you have some issues with it. With generated code, it goes over everything you have in your database one by one, and it generates code probably very similar to what you would have had written yourself. A little bit of abstraction, a little bit of composing of wheres, but that SQL statement, that's important, it's gonna be there. And this becomes more and more of an issue when your SQL queries get more and more complex. I don't know if you had the same experience like me, but whenever something gets more complex in my ORM, and I don't know why it's not working, I'll often just do .to_SQL to see what it's even trying to execute. Because I usually know what I want to run. You probably as well. You kind of know to what SQL query you're trying to get. So why go through so many loops to get there? This shouldn't be a surprise, but abstraction also has a cost in performance. I would never advise for someone to go to generate code just for performance. I think it has to be a bit broader look at what you're using and why you're using it. But it is interesting to take a look and see how much reflection and all of that abstraction costs you. And now to my favorite part, which is generating decorators. So, decorator pattern by itself, it has nothing to do with generating code. And I will go a little bit into what decorator pattern is. So you have your object, it has some logic, maybe more complex, maybe less, but you will probably have to add to it a lot of non-functional complexity as well. Like tracing, metrics, retrying, caching, and so on and so on. But you kind of want to keep it simple. within a logic. Maybe logic is complex enough that you don't want to introduce more and more and more into that because it's going to become unreadable. So with the decorator pattern, you take that and you wrap it with traces, with metrics, maybe with authentication. And during setup, you just compose all of that together and you have working solution. Now, in my team, we had some issues with telemetry. We always wanted more metrics, more tracing, and we struggled with it a lot. We tried to change our behavior, but it was not working. It was always some kind of struggle. And this is where generating decorators came. We use it heavily for traces because when you take a look at this example, this is a service with trace. Doesn't really matter what it does. If you take a look at the tracing part, it looks very similar. You start a trace, you make sure that it has an end. If there's an error, you make sure that you raise it. And what it shows us is that you can take that code, create a template out of it, and that template can be the same for entire service or maybe for your company. And you can run it for all of the interfaces that are more public facing, all of the interfaces that you want to make sure that you're keeping track of. And that's what we did. We took those generators, we put them there, let everyone know how this works. And now, if someone puts a generator in front of a service, another person that comes and adds another function, another method, the tracing part will be set up automatically for them. They don't even have to think about it. It can be done the same with logs, with metrics, with retrying if you're struggling with that. And if you're building something new, then adding those decorators is very simple. Once you have a template ready, you point that with just one special go generate comment towards that interface, and it's going to be generated. And all you have to do is then, during a setup, which I'm going to show you a bit later, to wrap it. And that's it. And you have your traces in place. If I manage to spark your interest, as everything, code generation is not free of its issues. I wanted to show you some of the issues you're going to hit and some of the solution that I propose with it. First one is committing your generated code. If you pull anything from Git, you should be able to run it. It helps a lot with building, reduces the complexity, makes it more performant because it doesn't have to generate all of that. It makes it easy for your team members to actually see that, hey, you changed something, it seems not a big deal, but hey, this changes 20 other files. It also makes sure that your builds are reproducible. You don't have to wonder, what kind of version of generator did I use? Is it the same code? Is it the same on production, on demo, on staging, on my local? And please check it in your CI, because we as developers, we sometimes forget to run it. So you can actually make sure in your CI that, hey, what you committed as a generated code doesn't match with what my make generate says it should be. And this brings us to the next point, which is make sure that there is some kind of file, I use makefile, with all of the commands necessary for installing all of the tools and making sure that your code is regenerated. It kind of uses GoGenerate to make sure that every generator in your file, in your project, is executed. It makes sure that you're installing the same tools with the same versions, and it's very important to install the same version. Don't ask me how I know. And I personally like to format my generate code because this is something I'm gonna be reading. Others developers will be reading as well, so there's no reason for it to take 400 characters in a line. Now let's do some short live coding of how it actually looks like to work with generated code. It's gonna be hard. Okay. Yes, I'm using white IDE. That might be the most controversial part of the entire conference. Cool. So there is already a payroll gRPC service built here. It has some methods. And what we're gonna do is we're gonna go in and we're gonna add a new RPC method and kind of see how this works with our generated setup. So here's my proto, and I'm going to add get payslip. We're gonna use get payslip request. It's gonna return payslip instead of payslip response because why spend time on this right now? We're gonna keep it very simple. Because it's not the, And now that we have our get payslip RPC method, we're gonna go and run what I preach, make generate. Should work. Okay. So now I have it running in the background. So you can see that after it generated and restarted, we have some errors. But that's good. That's what we want. We added RPC method and we have not implemented that. We want there to be an error. It says that it is in payroll service auth. Let's go there. Oh. No. It wouldn't be a demo if everything worked. Come on, F12. We're gonna go to the setup first so we can kind of see how it looks. So we have our pair service. This is generated, or it depends on generated interface. Then we wrap it with authentication, and then we wrap it with a logger. Both of those are decorator pattern in use. So it complains about not having get payslip method. With our IDE, it's quite simple to solve. We just implement it. I think I have my code somewhere for this because it doesn't really matter what it does. But you can see that we have all of the requests, we have our payslip, everything here is generated for us. And now we can return this. And when we save it, it should still complain that there is an error because we have another decorator that is actually not generated. And that decorator is our authentication. And this is kind of a nice way of showing you that Go generate sometimes goes very, very hand in hand with decorator pattern. Because as you can see, we wrap all of our previous methods with check that the user who's accessing that has a permission for it. So it is on purpose that we throw an error here because we want user to, or developer to be, oh, I have to check a permission. If it happens implicitly in the background, it's very easy to forget, it's very easy to miss. Top-notch security. Yeah. And now we can see it built, so no more issues to solve, and it is working. And what is cool about it is if we go to our Postman to fire a get payslip, this is what we put there. Doesn't really matter because what's cool about it is you can see that we did nothing to have logs there, but because we have set up our decorator pattern with logs, it is logging before it entered the get payslip method, and it is calling what's coming afterwards. And this is what my team used extensively with tracing. Cool. To summarize, what did we learn? When you have schema, you don't have to repeat yourself. You already did a lot of work to make sure that your schema is top-notch, and you don't have to write the code in Go for that. Leave that to generators, leave that to other machines. Compiler is your friend. All of the errors it gives you is probably errors you would have missed during functional review, and errors that maybe your customers would get. So be thankful for every error that you can move towards the compiler instead of to functional testing. And last but not least, if you want to implement a change in your team, maybe think about doing that through automation. Because if you want to change something and you make it easier, then maybe your team will actually be doing that. Those are tools that I recommend for using for gRPC, GraphQL, database, and decorators. I use them extensively in production, and all of them are very reliable, so I recommend them. And this is a QR code to the repository with the code we just changed a little bit and executed. It uses a lot of things we talked about in this talk about decorators, about ORMs, about gRPC. You can find it there, and there is a link back to this presentation. And yeah, thank you for your attention.
Daniel. Can you hear me? Yes. Thank you so much for your talk. So let's pass to the questions.
Yeah, thank you for the presentation, Daniel. And I have a question. Have you considered using generators also for the business layer of your application?
I have not, but kind of probably depends what kind of business you have, at least within mine. I mean, I kind of see every problem being a bit different. So maybe you could elaborate a little bit.
Yes, so for example, I guess some design patterns, they require more boilerplate, even on the application layer, for example, something like domain-driven design, and so that kind of thing. If you have a lot of adapters between the layers, and which can be considered also as a boilerplate.
Okay, yeah. So in that case, I did not think about using generators for business layer itself, but I did thought about using them for generating DTOs and mappers between the layers, because if it is true that if you go a bit more into domain-driven design, you have a lot of layers. You have your infrastructure, you have your service layer, and if you're doing it by the book, then you probably should pass DTOs and not reuse the same modules, right, to kind of enforce that. And yeah, this is something that I thought about, but there's no good library for that. So maybe we should create one.
Okay. Any other question? Yes.
Thank you very much for the talk as well. I'm curious, are there any situations that you can foresee where generated code is not a boon but a detriment? Would you not recommend to use generated code in some certain situations?
Good question. With every pattern, you should know where it's good and where it kind of becomes a bottleneck. I'm very careful with introducing generated code, even though I gave an entire presentation about it. I kind of try to be very, very diligent where I use it, and those parts, and usually it kind of comes back to, do I have a template? Do I have a schema already for it? And within those cases, I have not found anything that makes it harder to use. I mean, for example, with ORM, there were cases where the ORM SQL boiler did not generate everything properly, but it kind of can be labeled as a bug within the system itself, the library itself that I'm using, and it would not have been solved by using something else that generates code. So I don't know if that answers your question. Yeah.
Okay. Yes, we have two, so okay.
Hey, Daniel, thanks. Is there any particular reason you didn't mention Open API specification? So, because you mentioned gRPC, you mentioned GraphQL, but you left out REST APIs.
Yeah, I left it out on purpose. First one being I do not have experience with that. And while looking through the libraries, I wasn't sure what kind of state it is. The idea itself should apply there very well, meaning if you have Open API standard and you have your schema there, it should be generated, but at least I didn't find anything that I could recommend here, so I didn't want to include it.
Just had a comment about ORMs. We use, where I work at VCS, we use Ent, which is an ORM that lets you declare your database schema in Go code, and it'll generate the SQL for you. It'll generate the DDL, create table, and so on and so forth. That's another option you can look at for generating SQL from Go, instead of vice versa.
Yeah, I used that previous job with PHP, but I always was worried a little bit about, like, I kind of know the SQL, and I trust that whatever I run is going to be executed exactly how I want it to run. The other way around, I think it's a nice idea to explore, but for myself, I kind of prefer to base it on SQL. But I guess depending on the use case, it might make sense.
Yeah.
Any other question? Okay, I think we're good. So thank you again, Daniel. Thank you so much.